Welcome back everyone. In the previous part, we explored how operator overloading makes classes more natural and powerful in C#. Now, we're going to expand even further. We'll learn how to override the toString method to improve how objects represent themselves as text. We'll dive into floating point and decimal types, essential for precision. And finally, we'll see how to overload increment and decrement operators, both prefix and postfix, for custom classes. These concepts aren't just tools. They are essential building blocks for creating professional, readable, and reliable code. Let's continue. The toString method is a fundamental concept in C#. Every class inherits it from the base object class. The purpose of toString is to return a human-readable string that represents an object. It is essential for debugging because it lets you easily inspect object data. It improves logs, outputs, and display interfaces. Without toString, when you print an object, you see meaningless information like a type name. Overriding it gives real meaning. In real applications, default toString isn't enough. That's why you override it using the override keyword. By customizing toString, you control exactly how your object is displayed, showing important properties formatted nicely. This supports the principle of visibility and transparency. Good software makes its internal state visible and understandable whenever needed. Here's a real example. In the carpet class, toString is overridden to display price per square yard, total square yards needed, total price. Formatting each value properly, currency, decimals, shows respect for the end user, clarity, precision, and relevance. Overriding toString turns your objects into first-class citizens in any user interface or log file. In addition to overriding toString, C# allows you to use format specifiers when converting numbers to strings. Example: C for currency, F for fixed point decimals, N for number format. Using format specifiers helps you control precision, localization, and presentation without extra work, supporting the principle of professional output formatting. Next, let's talk about floating point types. Float, 32-bit, single precision. Double, 64-bit, double precision, default for real numbers. Decimal, 128-bit, high precision, specialized for financial calculations. Why care? Because different types offer different trade-offs. Float and double are fast, but slightly imprecise. Fine for scientific data. Decimal is slower but incredibly precise. Ideal for money. Choosing the right type teaches the principle of using the right tool for the job. Presenting numbers with decimals in the right way isn't just about how they look. It's really key to making your program easy for people to use. Imagine seeing a price written as $1,000, 234.56 versus just 1,234.56. The first one makes the program feel much more polished and user-friendly. Programs that are professional understand that users have certain expectations for how numbers should be formatted, and they respect those expectations because those little things really do matter to the user experience. When you're working with money in your program, it's really important to be exact. Imagine you have a salary that is 5,075 cents. In your program, you can write it like this. Decimal salary is equal to 5,075 M. The M at the end is like a special instruction that tells the computer to treat this number as a decimal. This is important because decimal is very precise and won't make tiny rounding mistakes like other ways of handling numbers with decimal points, float, or double might. We'll show the salary on the screen in the way you usually see money, with a currency symbol, like a $sign, and commas where they belong. This shows a really important idea. When you're dealing with money, being accurate should always be your top priority. Key takeaways so far: override toString for human-readable object descriptions. Use format specifiers to control numeric output. Choose between float, double, and decimal, carefully based on precision needs. Professional software isn't just about making things work. It's about making things accurate, clear, and reliable. Now, refreshing operator overloading. Overloading lets your objects behave naturally with operators like plus, minus, equals, etc. The purpose here is intuitive code. Your classes should behave like built-in types whenever appropriate. In the vector class, we overload plus to add two vectors, star to multiply a vector by a scalar. This reflects the mathematical reality of vector addition and scalar multiplication. Keeping object behavior consistent with real-world concepts improves program readability and reduces mistakes. We also overload multiplication to be commutative. You can write vector star scalar or scalar star vector. Plus, we override toString to neatly display vectors as x, y. The principle here, make your custom types feel as natural and powerful as built-in types. In a simple program, we demonstrate vector addition using overloaded plus, scalar multiplication using overloaded star. By seeing results like 5, 9, and 6, 8, we confirm that the overloaded operators correctly mirror mathematical reality, reinforcing the principle of intuitive behavior in custom classes. And here's the output. Clean expected results mean that your overloaded operators improve the user's mental model. They can predict what your code will do without surprise. Quick summary. Use decimal for precise financial calculations. Use float and double for scientific data. Overload operators to make your classes behave naturally. Always override toString for clarity. This is the art of building classes that are easy to trust and easy to use. Extending operator overloading. Now we tackle unary operators like plus plus and minus minus. Unary operator overloading lets your objects increment or decrement themselves in a way that feels native and natural, essential for counters, iterators, and more. In the counter class, we overload prefix plus plus counter, prefix minus minus counter. Prefix operators update the value before returning, useful for algorithms where state must change immediately. Principle: correct handling of internal state changes matters for program correctness. Postfix operator overloading is slightly different. Return the original value first, then apply the increment or decrement. This supports subtle but important differences in program behavior, respecting the standard expectations developers have for plus plus and minus minus. The key difference in C# syntax for postfix operators is the addition of a second unused int parameter. This dummy parameter distinguishes the postfix overload from the prefix 1. This supports subtle but important differences in program behavior, respecting the standard expectations developers have for plus plus and minus minus. In a working program, we create a counter, apply both prefix and postfix increments, observe how values change. Understanding these differences is crucial for accurate control of object state transitions. Key difference reminder: prefix plus plus counter updates first, then returns. Postfix counter plus plus returns first, then updates. This small distinction can have major consequences in loops, calculations, and conditional logic. Knowing it cold is part of mastering professional programming. Sample output shows count 5, 6, 6, 7 clear, expected behavior equal good programming design. Overloaded operators must always behave predictably and sensibly. Finally, overload unary operators for richer object behavior. Always override toString for better visibility. Handle prefix and postfix forms correctly. Keep operator behavior predictable. Never surprise your users. Building powerful classes isn't just about functionality.